Find the volume of the parallelepiped whose coterminous edges are, these are the edges, vector A, vector B and vector C. If two rows and two columns are same, then the value of a determinant is equal to 0, C cross C is equal to 0, A cross A is equal to 0, B cross B is also equal to 0. Given A plus lambda is perpendicular to 0 means the meaning is nothing but A plus lambda B dot C is equal to 0. This is the given condition. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to teach very important concept. This is the last session of vector chapter. So definitely you will get at least one or two questions from this session. Okay. Now let me discuss the first thing as the box product, or it is also called as the scalar triple product. The scalar triple product or box product of three vectors. Suppose if A, B, C, vector A, vector B and vector C are any three vectors, then the box product or scalar triple product of three vectors is denoted as box A, B, C or A dot B cross C. The box product of three vectors is denoted as A dot B cross C or vector A, B, C box. Now let us consider the three vectors. Let us write vector A is equal to A1i plus A2j plus A3k cap. Another vector, vector B is equal to B1i plus B2j plus B3k cap, and vector C is equal to C1i plus C2j plus C3 into k cap. Then the box product of these three vectors is denoted as box product of ABC, or this is also equal to A dot B cross C, and this is given by determinant. The coefficient of x, I, j, k in vector A, vector B and vector C. Coefficient of I, j, k is I is A1, B1, C1, j is A2, B2, C2, A3, B3 and C3. So if we simplify this, that will give the value of A dot B cross C, that is box product, or it is also called as the scalar triple product. So the scalar triple product or box product of any three vectors can be determined by using this formula, that is nothing but the determinant of the coefficient will give the value. So the determinant, if you expand this, you are going to get a number. So it's a scalar quantity, that is why it is called as the scalar triple product. And what is the geometrical meaning of A dot B cross C? So this will give the volume of a parallelepiped whose coterminous edges are A, B, C. If A, B and C are the coterminous edges of a parallelepiped, then the volume of such parallelepiped is given by A dot B cross C. If you simplify this, the value itself will give the volume of a parallelepiped. That is one of the application of this scalar triple products. Now let us take an example. Now find the scalar triple product of vectors where vector A is equal to I plus 2j minus 2k, and vector B is equal to 3i plus 2j plus 2k, and vector C is equal to 2i minus j plus k. This is very important and very simple problem. Listen to me. Now what is the scalar triple product? Scalar triple product is nothing but box product of ABC. This box product of ABC is nothing but A dot B cross C. What is A dot B cross C? This is nothing but determinant the coefficient of vector A. Coefficients of I, j, k in vector A 1, 2, minus 2. Similarly, coefficient of I, j, k in vector B is 3, 2 and 2. And here for third vector it is 2, minus 1 and plus. Simplify this, plus, minus and plus, this is equal to 1 into 2 ones are 2, minus into minus, plus 1 2s are 2, again minus 2 into, this is gone, 1 3s are 3, minus 2 2s are 4, minus 2 into 3 1s are 3, minus 3 minus 4. So this is equal to 1 into 4, minus 2 into minus 1, minus 2 into minus 7. So this is 4 plus 2 plus 7 2s are 14. So 14 plus 4, 18 plus 2 is 20. So this is 20. The volume of A dot B cross C, the value is 20. This is a scalar quantity. So therefore A dot B cross C, that is nothing but The scalar triple product of the given vector is a scalar quantity, right? This is how we are going to evaluate. Let me take one more problem. What is given? Evaluate the box product of vector I minus j plus k comma 2i plus j plus k and 2i minus j plus 3k. It is given in the form of vector ABC. So consider this as vector ABC. What is the box product of ABC? The box product of ABC is nothing but A dot B cross C. That's nothing but the determinant. Add on the coefficients 1, minus 1, 1. Here the coefficients of ijk are 2, 1 and 1. Here the coefficient of ijk are 2, 1 and 2. This is plus, minus and plus. Expand. 1 2s are 2, minus 1, minus into minus plus 1 into. This row and column is gone. 2 2s are 4 minus 2 plus 1 into. This row and column is gone. 1 2s are 2 minus 2. So this is 1 into 1 plus 1 into 2 plus 1 into 0. This is 1 plus 2, that is equal to 3. So the box product of this is 3. The required answer is 3. That's it. Okay. Listen. So the box product of these three vectors is nothing but A dot B cross C. That is determinant 1 minus 1 1, 2 1 1 and 2 1 2. So this is gone. 1 2s are 2 minus 1 plus minus into minus plus. This row and column is deleted. 2 2s are 4 minus 2 plus 1 into 2 1s are 2 minus 2. 2 minus 1 is 1. 4 minus 2 is 2. 2 minus 2 is 0. 1 into 1 is 1. 1 into 2 is 2 plus 0. That is 2 plus 1 is equal to 3. The required answer is 3. That's it. Okay. Hope you followed this. Right. Now let us come to the next problem. Find the volume of the parallelepiped whose coterminous edges are, these are the edges, vector A, vector B and vector C. Now let us write down vector A is equal to 2i plus j plus 3k and vector B is equal to minus I plus 2j plus k. Vector C is equal to 3i plus j plus 2k. Now, what is required to find the volume? Volume of parallelo. So, volume of parallelepiped is equal to A dot B cross C. So, this is the volume of a parallelepiped, that is A dot B cross C is equal to determinant. Write down the coefficients 2, 1 and 3, then minus 1, 2, minus 1, 2 and 1, 3, 1 and 2. This is plus, minus and plus. This is 2 into 2 2s are 4, minus 1, minus 1 into this row and column is gone, minus 1 2s are 2, minus 3 1s are 3, plus 3 into this row and column is gone, 1 1s are 1, minus 6. Simplify this. 2 into 3 minus 1 into minus 5 plus 3 into minus 7. So, this is equal to 6 plus 5 plus into minus 7 3s are 21. So, 6 plus 5 is 11 minus 21 is equal to minus 10 cubic centimeters. So, the volume is equal to Cc. Negative sign indicates it is decreasing. That's it. Okay. Now, that is regarding this scalar triple product, the problems. Now, there are few important problems connecting to this. Let me do those problems. Now, this is very important. Show that the vector A, vector B and vector C are coplanar. So, for coplanarity, three vectors A, B, C are said to be coplanar if and only if their box product is 0. Now, let us write down the solution here. So, what is to verify here is to verify that A dot B cross C is equal to 0. To prove that this is equal to 0. Now, A dot B cross C, find out A dot B cross C. What is A? 1, minus 2 and 3. What is vector B? Minus 2, 3 and minus 4. Vector C, 1, minus 3 and 5. These are the coefficients of I, J, K in vector A, B and C. Coefficient of I, J, K, coefficient of I, J, K and coefficient of I, J, K. Expand this with respect to first row. This is plus 1 into this row and column is gone. 5 3s are 15. Plus into minus, 3 4s are 12. Again minus into minus, plus 2 into this row and column is deleted. 2 5s are 10. minus 10, minus into minus, plus 4, plus 3 into this row column is gone, 2 3s are 6, minus into minus plus 6, minus 3. So this is equal to 1 into 15 minus 12 is 3, plus 2 into minus 10 plus 4 is minus 6, plus 3 into 6 minus 3 is 3. So plus 3, 6 2s are 12, plus 3 3s are 9. 9 plus 3 is 12 minus 12, this is equal to 0. Since A dot B cross C, A dot B cross C is equal to 0, therefore the vectors A, B, C are coplanar. That's all. So the vectors are coplanar since A dot B cross C is equal to 0. That's it. Very important. Okay. If A dot B cross C is equal to 0 means if the determinant of the coefficients of I, J, K for these three vectors are 0, then it is a coplanar. Then the vectors, three vectors are said to be coplanar vector. That's it. Now let us come to the next problem. So this is very important 3 marks question for 2022 examination. Now what is to prove here is to prove that the box product of the vectors A plus B, comma B plus C, comma C plus A is always equal to 2 times the box product of A, B, C. Vector A plus B, comma B plus C, comma C plus A is equal to 2 times the box product of A, B and C. Okay. Let us take LHS. LHS vector A plus B, comma vector B plus C, comma vector C plus C. Now let us consider this. Let us assume this as vector A, comma B, comma C, capital C. Now what is the box product of ABC? The box product of ABC is nothing but A dot B cross C. Since box product of ABC is equal to A dot B cross C. Now let us consider this as capital A, capital B and capital C. What is capital A? Vector A plus B. What is capital B? Vector B plus C. What is capital C? Vector C plus A. Followed. Now this can be written as A dot. A means A plus B, first vector dot, this is dot, product of these, cross product of these two vectors, that is B plus C cross C plus A. That's it. Okay. A dot B cross C. Vector B is B plus C. Vector C is C plus A. Now you just keep this as it is. Vector A plus B dot as it is. Now simplify this. Multiply it. B cross C. Vector B cross C plus vector B cross A plus vector C cross C plus vector C cross C. Now you just listen, this is as it is. Vector A plus B dot, this is B cross C plus B cross A plus C cross C, C cross C. Vector C cross C is always equal to 0 because cross product is nothing but the determinant coefficients of I, J, K for the first vector and the second vector. Since C cross C means if 2 rows and 2 columns are same, then the value of a determinant is equal to 0. C cross C is equal to 0, A cross A is equal to 0, B cross B is also equal to 0. So this becomes 0 plus this C cross A as it is. Right. Now this can also be written as, just I will write, I will go to the next. Before that, let me explain once again. This is of the form vector ABC box product. The box product of ABC is A dot B cross C. What is A dot B cross C? Vector A plus B dot B plus C cross C plus A. Multiply these two. B into C, BC, B into C plus B into A, again plus C into C plus C into A. Now since C cross C is equal to 0, the remaining steps are same. Now I will go to the next page. Now that is equal to vector A plus B dot, what is remaining? B cross C plus C, B cross A plus this is gone 0. Next is C cross A. Now let us take very simple, just put A dot all the three vectors plus B dot all the three vectors. So this can be written as A dot B cross C, observe carefully, plus A dot A dot B cross A plus A dot vector A dot C cross A plus similarly B dot vector B cross C plus B dot vector B cross A, B dot vector B cross A plus B dot vector C cross A. Right. Now, so A dot B cross C is nothing but the box product of A, B, C, right? What is A dot B cross C? Box product of A, B, C. Suppose if it is like this, A dot B cross A. So A dot B cross A means 2 rows and 2 columns are same. If 2 rows, 2 columns are same means 0. Similarly, B dot B cross A. B dot B cross A. Here B and B are same. That's equal to 0. If 2 vectors are same, then it is 0. So this is A dot B cross A is 0 plus A dot C cross A is 0. B dot B cross C is 0. B dot B cross A is 0 plus B dot C cross A can be written as the box product of vector ABC. See, only first and last are box product, remaining are all 0, because if 2 rows are same, then the value of determinant is 0. So then what is left over is box product of ABC plus box product of ABC. How many box products are there? There are 2 box products, that is 2 times the box product of ABC, that is your RHS. That's it, right? See, just put A dot for all the 3 vectors plus B dot for all the 3 vectors. A dot B cross C is box product of ABC. This is 0 because 2 vectors are same. This is 0 because 2 vectors are same. This is also 0, 2 vectors are same. This is also 0, 2 vectors are same. B dot C cross C is nothing but again box product of ABC. So ABC plus ABC is equal to 2 times the box product of ABC. That's it. Okay. Hope you followed this. Very important. You may expect this for the 2022 examination for 3 marks. Right. Now let us come to the next problem. Similar type problem. Okay. Prove that the box product of vector A, vector B, comma vector C plus D is equal to box product of ABC plus box product of ABD. This is also an important problem. Now, here let us take LHS. What is LHS? LHS is box product of vector A, comma vector B, comma vector C plus D. Now, as I told, this is box product of ABC is nothing but A dot B cross C, B cross C plus D vector. Okay. Now, this is equal to, just keep A dot as it is, multiply. This is B cross C plus B cross D. Now put A dot this vector, A dot B cross C plus A dot B cross D vector. Observe carefully, A dot B cross C, this is nothing but the box product of vector A, B and C plus A dot B cross D is nothing but again the box product of vector A, B and D. So this is nothing but the box product of vector A, B, C plus the box product of A, B and that is your answer. That is the required RHS. See, vector ABC plus vector ABT dot product. Right. So, vector A, vector B, comma vector C plus D box product is nothing but A dot B cross C, A dot B cross C plus D multiplied B cross C plus B cross D. Put A dot for these 2 vectors, A dot B cross C plus A dot B cross A. A dot B cross C is nothing but box product of ABC. A dot B cross C is nothing but box product of ABD, which is the required answer. Box product of A, B, C plus box product of A, B, D. Right. Okay. Hope you followed. Now let us come to the next problem. Now, this is also a very important problem. You may expect this type of problems either in vectors or 3D geometry. So, same type of problems we are going to study in 3D geometry also. Now, so find x such that 4 points A 3, 2, 1, B 4, x, 5, 4, 2, -2 and 6, 5, -1 are coplanar. This is also important problem, right? Now, let us solve using vector concept. the solution for this is just find out the box product for the vector AB, vector AB, vector AC and vector AD. This is equal to 0. Box product of AB, AC and AD is equal to 0. Now first find out AB and then AC and then AD vectors. Substitute, you will get the answer. That's it. Now let us find out vector AB first. Vector AB is equal to OB minus OA vector. Okay, what is OB minus OA? That is 4, x, 5 minus 3, 2, 1. So this can be written as 4 minus 3, x minus 2, 5 minus 1. So therefore, the vector AB can be written as 4 minus 3 is 1i, again plus x minus 2 times j plus 5 minus 1 is 4 times the vector k. Vector AB is equal to I plus x minus 2j plus 4k, right. Now similarly find out AB then AC vector. Vector AC is equal to OC minus OA vector. What is OC vector? OC vector is nothing but 4, 2, minus 2 minus vector OA is 3, 2, 1. So this is equal to 4 minus 3 is 1, 2 minus 2 is 0, again minus 2 minus 1 is minus 3. So therefore, vector AC can be written as I plus 0j minus 3k. This is vector AC. Okay, AB and AC. Find out AD and simplify. That's it. Okay. Now I'll go to the next page to find the vector AD. Now therefore, vector AD is equal to OD minus OA vector. So what is OD vector? That is nothing but 6, 5, minus 1 minus OA. OA is 3, 2, 1. This is equal to 6 minus 3 is 3, 5 minus 2 is 3, minus 1 is minus 2. So therefore, vector AD can be written as 3i plus 3j minus 2k. Okay. Now find out the box product. Now the box product of this is nothing but the box product of this is AB, vector AB dot vector AC cross AD, this equal to 0. So the box product of this is, that is determinant, the coefficient of ijk for the first vector is 1, x minus 2 and 4 is equal to 0. AC 1, 0, 3, 1, 0, minus 3 and the last vector is 3, 3, minus 2 is equal to 0. Simplify. If you simplify, you will get the answer. I will solve here. Let me solve this. This is 1 into 0 minus into minus plus 3 3s are 9 minus x minus 2 into this row and column is gone. 1 2s are 2 minus 2 minus into minus plus 3 3s are 9 plus 4 into this row column is gone. 1 3s are 3 minus 0 is equal to 0. Now simplify this. So that is, I'll write here 1 into 9 minus x minus 2 into 9 minus 2 is 7, then 4 into 3 is equal to 0. This is 9 multiplied by 7, 7x minus into minus plus 7 2s are 14, 4 3s are 12 is equal to 0. Now just what is left over? 14 plus 12 plus 9. 14 plus 12 is 26. 26 plus 9. 26 plus 9 is 35. 35 minus 7x is equal to 0. 7x is equal to 35. X is equal to 35 by 7. Okay. So that's equal to 35 by 7 is equal to 5. 7 5s are 35. So therefore, the value of x is 5. Here the value of x is equal to 5. That's it. This is how we are going to solve this problem. Okay. So just find out the determinant of this. Since determinant of this is equal to 0, simplify. First row, this is gone. 0 into 2 is 0, minus into minus plus 9 minus x minus 2 into 1 into minus 2 is minus 2, minus into minus plus, 3 3 is a 9, plus 4 into this row and column is gone, 1 3 is a 3, minus 0, this is 0, 3 minus 0 it is, this is 0. Then simplify this, 1 plus 9, x minus 2, 7, 9 minus 2, 7, 4, 3 minus 0 is 3. So this is nothing but 9 minus 7x plus 14 plus 12. So 35 minus 7x is equal to 0, 7x is equal to 35, therefore x is equal to 35 by 7 is 5, right. Okay, this is also very important. In 3D geometry, straight away we can write the formula like x2 minus x1, x2 minus x1, x3 minus x1, x4 minus x1. Similarly, y2 minus y1, y3 minus y1, y4 minus y1, z2 minus z1, z3 minus z1, z4 minus z1, determinant is equal to 0. Simplify, you will get the answer. That is in case of 3D geometry. Now let us come to the next problem. What is the next problem? Find the sum of the vectors. These are some additional problems, like find the sum of the vectors. There are 3 vectors given, we have to find the sum as well as the magnitude of a plus b plus c. Simple problem for 2 marks. Vector a plus b plus c, addition of 3 vectors, that's it. So this is vector a is I minus 2j plus k, plus vector b is minus 2i plus 4j plus 5k. Then vector c plus c is vector I minus 6j minus 7k. Add corresponding elements of I, j and k. Coefficient of I is 1, coefficient of I is minus 2 plus 1 into I. Next, plus j coefficient minus 2 plus 4 minus 6 times j, plus k coefficient. Coefficient of k is 1, here it is 5, here it is minus 7 into k cap. So 1 plus 1 is 0, 1 plus 1 is 2 minus 2 is 0 I. Yes, 4 minus 6 is minus 2 is minus 4j. Again plus 5 plus 1 is 6 minus 7 is minus 1 times k cap. So this is 0i minus 4j minus k cap. So therefore the magnitude of vector a plus b plus c is equal to root of 0 square is 0, minus square 4 square is 16 plus 1, this is root 17. That's it. So the value of a plus b plus c mod length of a plus b plus c is equal to root 17. That's it. See here, a, b, c, just add, otherwise it will get cancelled. See, I plus I, 2i minus 2i is 0, minus 2j plus 4j is plus 2j, minus 6k is minus 4j. Again k plus 5k, 6k minus 7k is minus 1k. So the value of 0 plus 16 plus 1 is root 17 is the required answer. Now let us come to the next problem. What is the next problem? Find the unit vector in the direction of vector PQ, where P and Q are the points. P is equal to 1, 2, 6 and Q is 4, 5, 6 respectively. Just find the unit vector. Now let us find out vector PQ. Vector PQ is equal to OQ minus OP vector. The position vector of PQ is OQ minus OP. OQ is nothing but vector 4, 5, 6 minus 1, 2, 6. This is equal to 4 minus 1 is 3, 5 minus 2 is 3, 6 minus 6 is 0. So therefore vector PQ is equal to 3i plus 3j plus 0k. Find out the magnitude. Magnitude of vector PQ. PQ vector is equal to 3 3s are 9 plus 9 root 18. 18 can be as 9 into 2. This is nothing but vector PQ magnitude is equal to 3 root 2. Now what is required to find? Find the unit vector. Unit vector in the direction of PQ. Unit vector in the direction along vector PQ. Okay, unit vector along vector PQ is nothing but PQ cap. Vector PQ cap is equal to vector PQ divided by its own length. That's all. What is PQ? 3i plus 3j divided by the magnitude of PQ is 3 root 2. So, you can take 3 common factor, I plus j divided by 3 root 2. 3 and 3 gets cancelled. This is 1 over root 2 into vector I plus j is the unit vector. That's it. So, the unit vector along PQ is 1 by root 2 into vector I plus j. That's all regarding this problem. Okay. Let me take the next one more additional problem. Let me take the problem. Suppose if vector A is equal to 2i plus 2j plus 3k, comma, and B is equal to vector B is equal to minus I plus 2j plus vector k, and vector C is equal to 3i plus j. So, these are the 3 vectors such that the given condition such that vector A plus lambda B is perpendicular to vector C. Find lambda. This is also an important problem. So, what is the problem given? If vector A is equal to 2i plus 2j plus 3k, vector B is equal to minus I plus 2j plus k, and vector C is equal to 3i plus j, such that A plus lambda B is perpendicular to C, then find lambda. Now, what is the given condition here? See, the given condition is vector A plus lambda B is perpendicular to 0. Given A plus lambda B is perpendicular to 0 means the meaning is nothing but A plus lambda B dot C is equal to 0. This is the given condition. So, given vector A plus lambda into vector B dot C is equal to 0. Now, just find out A plus lambda B. Just A plus lambda B can be written as vector A plus lambda B. What is vector A? Vector A is 2i plus 2j plus 3k plus lambda into vector B. Vector B is minus I plus 2j plus vector k. Now, just multiply by this lambda. So, 2 minus lambda into I plus coefficient of j is 2 plus 2 lambda. Just multiply each and every element by lambda into j plus here coefficient of k is 3 again plus 1 into lambda into k cap. This is A plus lambda B. Now, what is the given condition? A plus lambda B dot C is equal to 0. Now, the dot product of this 2 minus lambda into 3 plus 2 plus 2 lambda into coefficient of j, 2 plus 2 times lambda into coefficient of j is 1 plus coefficient of k is 0. You can write 0 is equal to 0. That's it. Now, simplify 3 2s are 6 minus 3 lambda plus 2 lambda is equal to 0. So, 6 plus 2 is 8 minus 3 lambda plus 2 lambda is minus lambda is equal to 0. So, 8 is equal to lambda. Therefore, the value of lambda is, so the value of lambda is equal to 8 such that A plus lambda B is perpendicular to C. That means A plus lambda B dot C is equal to 0. That's it. So, these are few important problems in vectors. So, if you practice all these problems, definitely you will get the full marks in this vector chapter. So, these type of problems are very, very important for your annual examination. So, please practice, solve all the problems. Okay. That's all regarding this vector chapter. In the next class, I am going to take one more very, very important chapter. Thank you very much.